afternoon, ladies and gentlemen. I'm John.
I'm Haley.
I'm David.
And we're here to talk to you today about the magical world of concrete, specifically
ASTMs.
And
ASTM, American Society of Testing Materials.
is that what it stands for? I thought it stood for ASTM. No, I'm being silly. I'm not trying to make a joke. I thought ASTM International stood for AS, like it doesn't stand for, it's not an acronym anymore.
I guess that's right.
Yeah.
I guess that's right.
But we're also going to talk about interpreting ASTM. That was really fun.
And selectively using.
Oh, wow. My mom used to say I had selective hearing, so I know what that means. But before we get into that,
Spoiler.
check out our new
Concrete rocks.
What are these things? Yeah, we're getting these for the team. We're experimenting with some designs. I want to get some logos on the shoulders so we can,
Hulk it out.
yeah.
And it's not an advertisement for aggregate.
No, it's not. It's
It
just,
means concrete. Raw.
right.
Oh, yeah.
You know what it was? Whitney bought me one 6 years ago, and it's my lucky hoodie, and I take it with me on every trip, and the elbows are wearing out, I mean, everything is just wearing out. It's so old. So, yeah, the team got me this, and it's just flipping awesome. So, I'm actually giving this one to Dad.
Oh, good.
Okay, so we're talking about the interpretation of ASTMs. Where do we want to start?
Well, we know the value of ASTMs.
Right.
I mean, they are the standard for what they represent.
Mm-hmm.
And so, we need to go, admittedly, some of them are a little harder to read and understand, admittedly, but some of them are just to the point and quite good.
Can we say that there are two sides to the swing of the pendulum? One is ASTMs can be PhD dissertations, and then on the other side, the ASTM can be practical and scalable.
Yeah, we run into that. It just, some of the ASMs just look like they came out of a dissertation. I mean, they just kind of look that way.
I actually had a conversation with somebody last week about a British standard that I absolutely love. It's the BS 7943, and I don't want to say the author's name, but part of their dissertation, and it makes sense that it comes from that author, because one heck of a standard, just a beautiful, It's the ASR gel pat test, a gorgeous, gorgeous standard. But that being said, Haley and David, can you define what you think is, the purpose of ASTM and why we use ASTMs?
I would say the purpose is consistency.
Yeah, I think consistency is a very important point, that no matter who does the test, you can compare
Should be able to, yeah.
should be able to compare the data. So I think that's a major key, without a doubt. I think the other thing about the ASTM, I mean, it exists. I mean, we don't want to have to invent every test that we want to use. I mean, somebody's gone through the work and the effort and the comparison.
The gray hairs, the headaches.
The gray hairs, the headaches, the late nights and sleepless nights. Somebody's already gone through that, and then all these people, the 400 and some people, it's gone through the committee process and the
Peer
voting
review.
and the balloting and whatnot, and it's becoming a standard, international standard that all these experts agree with. And so that's not a small effort. That's not a small effort. Okay, maybe it costs $50 to $100 to buy that standard, but my goodness, look at all the work that went into producing it.
Absolutely, and I think it could be said, like the analogy that we were talking about before, if you're going to play baseball in New Jersey versus California versus Japan, I mean, it's going to be the same game. We're all starting off with the same rules, same type of playing field, so
Right.
there is no question if I'm going to compare a set of results from ASTM C39 down in New Jersey versus California versus Colorado, assuming they're certified, I know that they're doing it the right way and the equipment is calibrated the same way that I do mine, at a minimum, the same
Right.
way I do mine based on the standards.
That's right, and that's highly valuable.
Right. So we came up with the why we use these ASTMs. The purpose behind them is you're using a test to communicate and isolate the impact of your technology on a certain parameter of a mix. Now,
That's right.
It's not. It might not be that the ASTM does that, the ASTM might be an evaluation for specifications or an evaluation for materials where it's a collection of these different ASTM specified tests for you to specify a material. So ASTM goes different directions with how to use materials.
That's right, I mean, C39 is a, put in the cylinder, break it, report the data. So
Right.
it's a procedure. 494 is an A to B.
Right, so I have people who will say, well, we passed the ASTM C39.
Okay. I have no doubt there's people that say that.
Well, no, and it's not that they say it, but they have it on their technical data sheets.
Right.
So there's a company that we worked with, names never matter, but on the back of their technical data sheet, they said conforms to or meets the specifications of ASTM C39, 157, C666, blah, 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 down the list. Now, are those tests, like, are those standard specifications to perform a test, or are those things that give you a pass-fail?
They're how to perform a test.
Right.
39, yeah.
Now, we go to 494, that's something like, hey, use these tests, and it tells you if it conforms to this certain type of chemical admixture.
That's right.
A pass-fail, if you will.
It's pass-fail.
Right.
Right.
I love ASTMs. They're so cool. So that's, the impetus behind these ASTMs for the industry.
That's right.
Now, shoot, I think there was, the resolution. Sorry, technical difficulties. Magic.
Well, what do we don't like about ASTMs? That's the purpose of the next part of the conversation.
Yeah.
And for me, I'm currently working up a data set for ring cracking, and it's just...
Oh, we didn't do that part. I'm so
Yeah.
sorry. Sorry. So what?
That's right.
That's it. Sorry.
Right. Another half hour of editing. So, for me with the ASTMs, sometimes they're too much.
Yeah.
The 1581 I'm working at, you gotta take the square root of time versus net strain, you gotta do this, you gotta do that. What the client wants to know is, does my product crack sooner than another product?
Right.
That's what the client wants to know. So to be in total compliance with 1581, we've got to post all these 10 or 11
Right.
graphs and parameters and all that. And we've got to go tell the client, gee, you just want to know this, but we spent 10 times the money because
We have to conform.
we have to conform to 1581.
Have to.
So that's a problem.
And by the way, this is not coming from a technician or somebody in the admin side. This comes from our principal engineer who, if anything goes wrong, it's his fault. So this is coming from the most important source from our company.
Yeah, so I've got the stamp in hand and the line says...
Does it look like that or is it more like this?
No, mine looks like this.
Okay, good.
And it says, certifying that it complies with 1581.
Okay.
So to meet that, I'm gonna have to do all that mandatory reporting.
Right.
But if we talk to the client and all the client wants is, does it crack sooner or later than somebody else's product, then we can use 1581 procedures to find out that information, but it won't be completely compliant with 1581.
So why doesn't the industry just become more flexible on what they'll accept as viable data?
Oh, it's like I heard a million voices crying out.
Yeah.
It's a great idea.
It really is. And I think the ASTMs, the one we're currently writing, we're doing the tech staffing out for on a colloidal silica, we put that in. We put in paragraphs that say, by agreement between the purchaser and the manufacturer, you can do this or do that or whatever. It gives some flexibility.
Well, one thing, I agree, but I would take it a step further as another piece of this conflict. The second piece of it is sometimes it's not that they ask you to the ASTMs ask you to report too much. David makes this, says this joke of, sometimes it's a PhD dissertation. You look at the C156, and some people say they conform to C156. It's just a test. But to conform to to have your chamber, and the test that you're doing to conform to C156, well, you have to have a temperature of 98 degrees or 100 degrees plus or minus 2 degrees Fahrenheit, relative humidity of 32% plus or minus 2%, and then you have to have an evaporation rate of 2.4 to 3.2 grams per hour. Boom! Whew.
That's a lot.
That's a lot.
It's a lot, you know, it's 3 boundary conditions to meet, and, you know, yes, you can compare that number you calculate to somebody else's, but that's not an easy test to set up.
It's not a practical test. Every time you add, because to do that, you need to add like at least 4 systems, if not 5 systems, into your one controlled environment. And it's a semi-adiabatic environment. It can't not be an adiabatic. And adding all those systems in with the semi-adiabatic, now you change it to 6 systems. And the insulating environment, now you change it to 7 systems. Mathematically, you're just including deviation and error, compounding that deviation and error. So I wouldn't call it a practical ASTM. I don't think there are many ASTMs, and I'm trying to be kind here, that are practical. And you give me one ASTM that the entire industry as a whole agrees on.
39.
Nope. No, because you have maturity. You have an entire side of the industry. That is why companies like Intellorock, Geotech,
Yeah, true.
Floor, or whatever their names are, you know, have clients. Because we don't rely. Well, the cylinders were kept out in the cold, they wouldn't put under the blanket. Well, the cylinders were put under the blanket, they weren't kept out in the cold. You know, so I don't know of any ASTM that is agreed on the board, across the board.
Fair
So,
point.
Resolution.
Resolution. Sorry. Oh, I apologize. So resolution. So how do we get past these problems with the industry? It's too much reporting. It's just not realistic. Then it becomes so dang expensive.
Yeah.
So what is the resolution, principal engineer?
Well, I think Haley kind of nailed it. I mean, we need flexibility in the standard itself. And, you know, the client needs what they need. I mean, let's sit down with the client up front and say, we've got procedures that'll definitely find out what you want to know. But if you only want to know this one thing,
Right.
we'll use the standard procedure, but we'll only find and calculate that one parameter for you.
What about right now, though?
This might be impractical, but I think if you set yourself up as a reputable laboratory,
Right.
then
Expectation.
yeah, how can people say, well, they did this test, it doesn't meet the ASTM, so it doesn't matter at all? If people know Intelligent Concrete does good work,
I think, well, what you're going toward, if correct me if I'm wrong, what you're implying is if we don't do it per the standard, we're not doing correct work.
no,
We're not doing good work.
no.
Okay.
I'm
So you're saying, okay.
So if we set up ourselves up as a reputable company
Mm-hmm.
and testing firm,
Mm-hmm.
and we do a test, and someone in the industry sees it's not per ASTM, they'll still say, oh, Intelligent Concrete does good work.
That makes sense. Does that
Just
make
like
sense?
that paper you were saying.
Right.
So if you set yourself up,
You're talking about the microbial. There's a wonderful paper written by, I don't know if it's written by, but I know it's by, I believe it's by his group, Jason Weiss, Professor Weiss over at Oregon State. I was expecting you to do that. At Oregon State University.
Oh, hell.
Oh, hell. Microbial induced corrosion, and it's not, I don't believe it's an ASTM test now, and that's the issue, and then they created the test and blah, 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 what Haley is talking about. Yeah, and we have done just that we've created new tests, gone through the gray hairs, or no hair anymore, of proving it out, and then using it with our clients, like the sealing and healing study that we've done. Yeah, that's a really good point, Haley. It's a really good point.
So yeah, I think that's good. I think if there's an area that there is no test, then we go
Sealing and healing,
sealing and healing.
right?
We go, either we become the experts, which in that case we've kind of done,
Mm-hmm.
or we find an expert and we use the gray hair that they've created. But if there is a ASTM standard and we go out on our own and try to invent something new, that's going to cause some consternation.
Well, unless you have the data set that backs it up. ASTM's like, in multiple spots says, you're cool with changing it up, but you've got to have the data set to say, when I change everything up, everything's cool.
Right.
So, you know, that this is something that David said. I remember when he first started working here, I would, David would be like, hey, we have to change up this report, it has to include this. I would say, do we really have to do that, David? And he would say, what does the standard say? And that's the toughest part. When we told David about this video, he said, well, that's going to be a pretty short video. What does the standard say? Now, it has not been a short video, and we haven't even talked about the legal ramifications of all this stuff. Because that's the whole thing of it, right? If it's not done, I mean, we don't care about this stuff until somebody goes to court over, you know, a concrete not making strength, and now we have to rip it out in replacement, and we're talking about 2 million square feet of concrete that are 6 inches thick. So it's like 15 to 20,000 cubic yards of concrete, which is at $150 to $200 a yard. That's not simple money, and now you get the waste into it. All of a sudden, we're talking big money, and if you didn't do the ASTM right, well, whose fault is it?
Yeah, if you don't follow the standard.
All of a sudden, it becomes a question of, well, did the testing lab do it right? And now there's a potential lawsuit there.
Right.
So, I mean, all of this doesn't really become a concern until we talk about money being passed back and forth, especially with lawsuits. So, you know, Haley brought up with, you know, the flexibility of the industry. You know, that is such a awesome concept. It really is. But that is not a right now concept. That is a disruptive change to what we are currently doing.
Yeah, we deal a lot with product production, product development here. That's a lot of what we do. And so a lot of times we'll just use A to B. And so just the cracking is a good example. Does it crack sooner or later?
Right.
We use 1581 procedures. As long as the client wants that answer, and we use that procedure, and we get them an answer, then I think that is some flexibility. That, you know.
But that's not recognized throughout the industry.
Yeah, well.
And I think, I just drank water and got it all over me, sorry. No, and I think that's something that I heard in what Haley said, what you said, is that there needs to be recognition in the industry for flexibility in the use, application of the standards. Because there are often times when we talk to people who are not in the development industry, and the suggestion is to use the standard in a modified way. Thank you. I couldn't think of those words. I can only think of the sound effects. And that's something that I think a younger generation needs to do, because let's be honest, there are many awesome engineers out there, but there are very few awesome engineers like David who have spent the time in the industry. You know, one great thing about David is what he brings to our company is not just his awareness of new and emerging and innovative technologies, he's got 13 letters at the end of his name.
True.
And he just didn't get those by paying a subscription to something, right?
That's true. It wasn't like, you know, 2 PDHs. I mean, that.
Right.
You know about the PhD, that's 5-6 years. I mean.
Then there's the PE, which is at least 4 to 10 years.
Yeah, and then there's the fellow, which is, and the other fellow, which is the top 3% of the industry, so.
We should do another video about your letters.
No, I mean, that's a great point, because Haley is trying to get certain letters after her name. Brooke is trying to get certain letters after her name. Those letters have meaning to them. Like, I don't use the MSc at the end of my name because
You got the PhD.
it's almost meaningless. I know there are people who do use that, but we want to get, like, Haley's going after leadership, Green Road certification. Whitney's going to be a PhD and a PE one day. And Brooke is going to be accreditation. So all of us are trying to do that. And with David's letters, it has meaning that gives credibility to the things that he says.
That's right. So if we sit down at the table with a DOT or somebody like that, and we say, well, you know, this is a practical answer. This is a useful answer. This is an answer that can be used for pavement or highway or whatever. And yeah.
I was just saying, for the flexibility, those people that you're talking about in the industry, they're not as flexible as David. David sees the need for growth, and there's only one way that we can get there, and that's adaptation and flexibility. A younger generation can help bring us that in, because, gosh, I was talking to a DOT 3 months ago, and new technology that they need, because they're running out of the old technology, and they said, well, sir, I'm sorry, but it doesn't say that we can use that technology in our 2019 engineering specifications. I don't know what to tell you. what does the standard say? And I was like, you have to be kidding me. You're throwing away hundreds of millions of dollars worth of concrete today because of these dumb specifications. And you know what this engineer said to me? You remember? Sir, I can see that you're very passionate about this topic. I'm like, really? That's what you got out of this? That's what you got out of that conversation, that I'm very passionate? Good call. But, so, yeah, just making a full circle.
And one of the things we said is, you know, as the principal engineer, as the signatory authority, I will not make a decision without data.
Right.
I've got to have
Understood.
data. On the other hand, if I have data, I should be willing to make a decision.
Right. I think to do that, though, for flexibility in the industry, am I even in the screen here? You have to also be part of the industry. There has to be a commitment to take part in ASTM. And right now, I don't. I'm going to become a member of it, and you know, David's going to be my mentor, but I tend to get into too many bare knuckle fights already, and it's not my fault. Last time we'd gone through the whole thing, and I got into no fights, right? And we're going for lunch, and then right at the end, some wants to start with me, tell me what I can and can't do. Oh my gosh, whew. David had a point. Yeah, I almost got into a fight. That's the first. It wasn't my fault!
It's a forum for discussion.
Right. I wouldn't want to go to blows and boat up. It was awesome.
Alright, so ASTM, thumbs up, thumbs down.
Thumbs up. I love ASTM.
Yeah.
CSAs, ENs, love them. Absolutely, take them for what they're worth though. If you're doing, I learned this during my PhD, if you're doing compressive strength, you cannot understand the molecular or the impact on the molecular kinetics of cement hydration based on compressive strength. Comment on the data that you have in front of you, not rabbit out of a hat.
That's right. Yeah.
Okay.
Thanks for watching. Don't forget to like and subscribe.
Ding that bell for notifications!
Go Concrete!
Bleed asphalt!